made an illustration of what we are going to be making today, and this should be able to convey the idea of the REST API. So the idea of a REST API is that you have some clients that send a request to a server. So the API is an HTTP server, and this HTTP server will perform some kind of an action like read or write to a database, perform some logic, and then it's gonna send a response back to the client. So we always work with requests and responses, right? And this client could be a web browser, or it could be any kind of HTTP capable application, but we're gonna use Postman for this specific instance. First of all, what we're gonna do is we're gonna figure out, do we have everything we need to get started? To get started, we need .NET version 6 installed on your machine. The easiest way to find out if you already have it installed is to open some kind of terminal. On a Windows machine like this one, I would use command prompt. So if you write cmd, in your start menu, it should show up, and you write .NET version. So I have .NET version 6 installed. If you don't have .NET version 6 installed, the easiest way to get it is to just Google, download .NET 6.0, go to it, and then pick whatever installation is for your machine. And there are many different versions, and also something called .NET Core. It should just be called .NET. The second thing that we need is an HTTP client, and we're going to use the one called Postman. And Postman is available for free download if you go to postman.com/downloads, and it should be able to detect the operating system you're on. So for me, it will say download Windows 64-bit right here. And the third thing we're gonna need is an IDE, and this is just to be able to write the code somewhere. You can also use a text editor. Personally, I'm gonna use JetBrains Writer, and if you want to have your menus set up the way that I also have, you should download this one. I use the default preferences, so I don't change anything. You can also use Visual Studio, but of course your user interface will look slightly different if you use Visual Studio. The first thing we're gonna do is we're gonna create an empty solution. So now we're inside Writer, and this is the menu you get for making something new. So if you just click the uppermost option here, it will say empty solution, and we're gonna give this one a name. And we're gonna put it inside of this directory. And for now, we're just gonna ignore the Git repository, but that could also be a good idea if you want version control for your repository. And we click create. After a couple of seconds, it should be done building this solution. Right now, it doesn't contain anything, and it will be on the solution overview. So you can also click the file system, and you'll see you have something called .idea, and we're not going to touch that at all. And then you have the solution file here, and we're not going to touch this one either. What we're going to do is we're going to right-click this, and we're going to add a new project. So one solution can contain many projects, and these projects are where our actual code is going to be. So now you get a bunch of different options here, and what we're interested in making is the .NET Web API. So right here it will say type Web API under the option ASP.NET Core Web Application. So there are many types of web applications. We're interested in making Web API, and we will just call this one API. And make sure that you're picking .NET version 6 here. If you don't have anything else installed, it shouldn't give you any other options. And we click create. we're not actually going to be using the weather forecasts for anything in particular, but I'd like to just run the application so you can see what happens when you execute this program. First of all, we're going to go into the folder called the API. So by default, we'll be inside of the solution folder. When we open up the terminal, we're going to go to this one called API. That's why we write cd API. And then we write .NET run. And now the API is going to start up. And after some building, what we should get is some addresses that the application is running on. So you can see we have this address, localhost port 7113 and localhost port 5008. And these ports come from right here. So if you want some other ports that are maybe easier to remember, just go put them here. I like to do that because then I don't have to memorize new ports all the time. So if we shut down the program now by clicking Control C, and we can just click up now because we already have a previous command that was .NET run, and we can run this command again because it's the same command every single time, of course. And we will now send a request to our server. So what do we actually write when we want to request some data from the server? Well, we take API's URL. It could be any of these two. And we're just going to copy it. And we're going to open up Postman here. So this is our HTTP client. And you just write new. And then you write HTTP request. And then you have an address bar here. Inside this address bar, put the URL. And then you just click slash and then the name of the controller. So we have this file called the weather forecast controller. And the weather forecast controller will be residing under the address weather forecast. And then whatever's gonna get to in here is depending on which routes we have over our methods. So right now, this one, we just deleted the name. The name doesn't impact the route. So it's actually a very misleading default application they put in here. But we're just gonna request this method by calling this route. And this route will just be whatever this one is up here. And this one up here is just gonna take the name of the controller, right? So we click send. And now we get all this data. This is data from the weather API, and this is not really anything we're going to use for something. This is just to show that we have a connection to the API from some client now. So what we can do now is go ahead and just delete this one, because we're not going to use it. And we're not going to look at the project solution, and we're not going to look at any launch settings. We can also delete this one. This is just an entity class for the weather forecast, and we don't need this one either. And now we really only have one file left, and it's the one called program.cs. Program.cs is the starting point of the application. And this is where a lot of configurations are made. We're not going to change anything in here, but I'd like to just say this is where your application starts out. So for now, what we're going to do is we're going to create a new controller. So we click class/interface, and let's make something that is called ProductController.cs. And now we have a public class called ProductController. But what we're going to do is we're going to implement an interface called ControllerBase, like this. And now we get this new using statement up here. And just above our class, we're going to place an attribute called API controller. And we're also going to make a route for this one, so we know what to write inside of the address. So we write route, and then you make a parentheses. And in here, we're going to put a string, and we just say square bracket, controller, square bracket. So now if we make a request to our localhost port 5001/controller, we will get to this controller. But now we also need some endpoints. So what can we do to actually make an endpoint? Well, we write the HTTP method. So we have different methods that we're working with when we make HTTP requests. And the most basic one is called get. So we write HTTP get inside of an attribute like this. And then right underneath, you make a function. So that could just be public object hello world. And because it's C#, we should write our functions like this and not camel case. And then we're just gonna write return hello world. And if we run this one now, just click up, .NET run, and we go into our Postman HTTP client, delete this thing where it says weather forecast. We can just write product, because now we're no longer interested in getting any weather forecast, right? And once it's running, we will send an HTTP request. And here we have it, send, and it'll say hello world. So now we can communicate with this new controller. Of course, this is not anything valuable at all. So what we're gonna do is we're gonna start getting a database coupled with this application. But we're not gonna build the database inside of the same project. We're gonna create another project under the same solution. And that project is gonna be concerned about sending queries to the database. So what we're gonna create now is called a class library. You shouldn't make another web API, you should make a class library. And we can just call this one infrastructure. It's not so important what it's called, but the word infrastructure typically defines things like a database and connection to, let's say, email clients or some kind of external entities that we want to communicate with outside of our own application. And just check that it's also .NET version 6. And now it's going to create this project, and we should have a class in here that's just called class1 inside of a file called class1.cs. So this is completely empty right now, and it has no dependencies. And we're actually going to start off by giving it a dependency. And the dependency we're going to create is to another class library just called entities. So right now we don't really know what this product thing is. We haven't defined any kind of product. So we'd like to just start off by making some product that has some properties. So we can go inside of entities now, and then we can just change this class1 thing, choose refactor and rename, and then you just pick whatever you want to call it. We want to call it product. And by default, writer should be capable of also renaming the file. That's very cool. So what do we want to describe these products? Well, we want to find some kind of unique identifier for every single product. So that is, of course, an ID. The way we would make a property inside C# is we write the type here and the modifier before the type, and then we write the identifier. So that would be ID. And then we write get and set. So now we have public int ID, get set. And then we also need something else. Let's say we need a name for a product. Public string name, get set. And properties inside of C# should be capitalized. That's why I don't make these lowercase. And let's say we have an int that is price. So every product has a price, right? And now we have our entity class inside of our entity project. And now we're going to add the dependency. So we go under dependencies here, under infrastructure, and then we say infrastructure should be depending on entities, because we want infrastructure to know about this product thing. So you write add reference, and then you just tick off this box and you click add. And if you want to check that you have the dependencies necessary, you just go under projects and you should see that you have this thing here. And now it's ready to go. Of course, we need one more dependency inside of infrastructure, because infrastructure is gonna use a database, right? And we need some software to actually communicate with this database. So we're gonna add reference. Well, not add reference, we're gonna manage NuGet packages. And then we get this menu up here. It also exists down here. And we're gonna write entity framework core.SQLite. So it has a very long and very specific name, and there are very many packages named something similar to. So it's entity framework core in one word, and then it's .SQLite. And the one we're gonna pick is this one. It's named exactly that. And we're gonna click this little plus sign here and click install. And then once it's installed, we should be able to click packages here, and then we'll see that we have entity framework core.SQLite installed. So because our API communicates with our infrastructure, it has to somehow send queries to a database from the API, right? Because the controller here, this is where the client starts to communicate with our backend system. We also need a dependency from the API to the infrastructure. So we're going to add a reference here, and then we're going to say API should know about infrastructure. And we're going to go to .NET version 6.0 here, and we're going to go to projects. And we see that our API knows about entities and it knows about infrastructure. And why does it know about both? Well, it knows about both because infrastructure itself already has knowledge about entities. And therefore, API, by that convention, also knows about entities, which means in here, we can create a new product. So if I write var product equals new product, like this, it will ask me, hey, do you want to import this? And now I can make a product. So I know about the entity class inside of the API itself. And that's very cool. So we're going to start working on the contents of this infrastructure project here. And we're just going to start off by renaming this. So first of all, what we need is a thing called a database context. So we can call this one ProductDB context. And now we have a class called ProductDB context, and it needs to implement an interface. So we write the colon for implementing interface, and then we write DB context. And we can see that we're now using Microsoft.Entity Framework Core. And now we need to make a constructor for our ProductDB context. So the way we would do this is we write public, and then the name of the class itself, ProductDB context. And inside of the parameters here, we're gonna put some configurations here. So we have something called DB context options. And these DB context options will come with a diamond bracket. And inside of that, we just put the name of our own class, and we can just call this one options. And then we have a colon here, and we write base, and then whatever we call the other variable here, options. So if you write OPTS, of course you should also just write OPTS right here. Second of all, what we're going to need inside of this ProductDB context class is everything that we need to define the database schema. So inside of a database, we of course would have something like a primary key. And there are many configurations you could make to a database schema. We would make those inside of a method called onModelCreating. The way we would syntax that is we will write a protected void, and we make this overridable like this, and we call it onModelCreating. And then we put a model builder in here, and we just call this model builder model builder. So inside of this function, we use this model builder to define things like the primary key. So if I now write model builder dot entity, and then I use the product entity, because right now we just have one entity class, and of course it's going to say, do you want to import this? And I say yeah, and I write property, and in here we have this little arrow expression. So I just write P for product, and then I make syntax like this, and I write p.id, because we're interested in making a primary key for our products table inside of the database. So first of all, we would reference the property that we want to be the primary key, and we use an ID, which is just a number, right? And what we're going to do now is we're going to call the function value generated on add, and that just means it auto increments. So this is our auto incrementing ID now. The last thing we need inside of the ProductDB context class is what's called a DB set. And a DB set can be thought of as a table. So the way we would write this is to write DB set, and then we get the diamond brackets again, and we put the entity inside of the diamond brackets, and we can call this something. I like to call it product table, just to eliminate ambiguity. Get and set. Some people, they would just call this product, but then you have two things called product, and that might be a little confusing. The second thing we're gonna do is we're gonna create a class inside of this infrastructure project called the product repository.cs. So inside of the product repository, we have all the database queries. So this is just a normal class containing some functions, and these functions will use the ProductDB context we just created. More specifically, it's going to use an instance of the ProductDB context. So what we would start off by doing is we make an instance variable. The way we would notate instance variables in C# is we would make this little dash here, a lower dash, and then we write like product context. It's not so important what it's called, it's just that we need to know that this is what we're going to use to communicate with the database. And then we make a constructor here. So we write product repository here, and we're going to inject the context we need into the product repository. So now we have a normal constructor here, and we write product context, DB context. And then you can just call it something. And inside of the scope, we say product context equals context. So this is a completely normal dependency injection, which means when we initialize our product repository instances, we will inject a context into the repository, and we will use this context to make all our queries. So what could a query be? Well, we could make a list of products, or we could insert a product or something like that. So we can make these queries inside of some functions. So let's have a public list of product. We call this get all products. And we're just gonna import this one. And then we write return, and then we take the context and we use the product table, and we can just write to list. So the to list method will just be a select all statement that will convert them to a list of the entity product. So that's exactly what we need when we just need to fetch all products. This is all right by now. Of course, if we had many products, we would need to somehow filter it or maybe also sort it. But this is good to just get started with. Second of all, we're gonna need an insert statement. So we're gonna make a public product insert product. And inside of the parameters, we're gonna write product like this. And what we need to do now is we need to trigger some kind of insert function that is existing inside our entity framework. So entity framework has a function that's just called add. And we just call this add method, and then we put this product here into the add method. So we would write product context, product table, add. And then we put the product in here. And what we always need to do when we need to save some data with entity framework is we need to take the context and we write save changes. And now we can return the product back again to whoever calls this method, right? By now we have some functions inside of this repository class that we use to query the database with. But one thing we still need is the actual database. And if we just want to get started, we can just make a file, because we use SQLite for local development, and we just add a file into the API folder here, and we just call it db.db. It's not so important what it's called and where it is. This is just used when we are actually developing stuff, when we start to get further in the process and we want to make things production ready. We wouldn't use this type of database, but for testing things locally on our own machines, this is all right. And right now there is just an empty file. So we actually have to create a database inside of this file. So what we're going to do is we're going to have some kind of function that can create that database. So we can just make a void called CreateDB, and then we use the context, right? Product context, and then we write database, because it's not a table we're concerned with here, it's a database. And what we're going to start off by doing is calling the ensure deleted. So of course, if we already have something inside of that file or database or whatever, we delete that first, and then we call ensure created like this. And this is going to make sure that all our tables are set up the way that we defined it inside of this class. So we're going to have a primary key for the table of products where the ID is the primary key. And if we make any changes, we can always call this function again, and then our database will look the way that we defined it inside of the model builder again. So right now, we don't really have any knowledge about the database from the program. We created the file, but the way that you would actually figure out where is this database inside of a REST API is you would go to the program.cs file, the startup file. Previously, we talked about how this is just configurations, and we're not really going to do a whole lot in here. One thing we are going to do is we are going to add the database context, and we are going to add a connection string to this context. So the way that we're gonna do this is we're gonna use this thing called the builder. We write builder, services, and then we write add DB context. And then we put whatever we call the context here. So this is a product DB context, right? Like this. And then inside of this parentheses, we write the options. So we write options, and we have this little arrow notation, and then we write use SQLite. And let's just go down one line here. And inside of here, we would put the connection string. So the connection string for SQLite is not containing a password or anything, because it's just a file on our machine. So we can just write string containing data source equals db.db. And this program file here is inside of the API, and db.db is also. So of course, if you place this somewhere else, you would have to make this path relative to wherever the API is. And this is the only thing we're going to add to the program.cs. The reason why we didn't do this earlier when we were making console applications is because console applications, they don't have the startup configuration like this. So in order to actually have this add DB context, we need to have the builder. And the builder is inside something called web application create builder. So we can use this when we're making a REST API, but we can't do it when we're making a console application. So that's why it's slightly different now. So we're gonna go to the controllers now. And now we actually want to make our endpoints such that we can read from the database and we can write to the database. And that means we are going to start off by creating some kind of constructor where we can have the injection of the repository. So we write a constructor, product controller, and then we do like this. So what we're going to put inside of here is we're going to write product repository. And we can just call this repository. And then we're going to make an instance variable here. So we notate that by underscore, and we're just going to call this one private product repository, and then the underscore, and we can just call this product repository like this. And we say product repository equals repository. So where does this actually get injected at? No, we're going to have to instantiate a product controller before we can add the repository, right? So we can go back to the program.cs here, and we're going to write just underneath what we wrote before, builder, services, and then we're going to write add scoped, and we're going to write product repository here like this. And let's go back to the controller, and now we have this endpoint that we call hello world. We're going to change that because now we actually want to get some data from the database because we've set up our repository, right? And we can call this public list of product, and we just call this get products, and it'll say, oh, you have to return a list of products, right? So what we're going to do is we're going to write return underscore product repository get all products like this. So let's try and test this one, right? But before we get that far, we're going to make another endpoint because, like we talked about before, the database is just an empty file right now. So we're going to make an endpoint that we can call just to trigger the ensure created function in the repository. So we're going to make a void because we don't really need to return anything here. Of course, we could return a string that just says database created. So we're going to do that. Well, let's write a string create d. Then we can write a product repository create db, and we can write a return db has been created, like this. And now we want to run this. Open up the terminal. Always close down the program before you run it when you've made any changes. It doesn't auto update. And as soon as it is ready here, we'll start sending the request from Postman. And there was one thing I forgot to add. You see, right now we have two HTTP GET methods. And the problem with that is they essentially have the same route. So I'm going to put this one inside of a route and call it CreateDB, like this. And gonna write .NET run again. So it's gonna rebuild now. And after a brief period of waiting, the program is now running. And the address that we have to enter is localhost 5001/product/createdb, because the route is createdb. And before that, we have the name of the controller, which is product controller. So what we do now is we write send, and now we will get this message, DB has been created. And that's wonderful. Now we can just delete this createDB, because if we want to call the method that we have above, return all products, we can do that now. Of course, we don't have any products inside of the database because it's empty. We can still send the request, and now we get back probably just this. So we want to make some products now. So we're going to make a new endpoint. And we're going to write HTTP post, because we're going to use a post endpoint to send data to the server. And let's write public products. And then we can just write create new product. Inside of the parentheses here, we're going to have product, like this. So before we can actually return a product, we need to write it to the database. And of course, we just use the repository that we've had created here. So we write return product repository, insert product, and then we just put the product inside of this, right? And what we do now is just rerun it. And if you're ever curious about the actual database queries that Entity Framework creates, you can see these inside of the logger here. And now it's running again. And let's switch this over to a post request. And we're still gonna write the same address here. So why doesn't it conflict? Well, it's because they are different types, so it doesn't matter that they have the same route. So now you can just go to body, and then you would write raw, and then we would go to JSON. So we need to send some kind of product object, and the way we do this is we make a curly brackets here, and then we write the key name. So key name is name of the property, and then a value. But because we want the database to add the ID, we'll just ignore that one completely. And then we'll write a name, because we have some name for the product. And this is a new product. And then there is a price, and the price is just going to be 10. So now we can send this JSON object, and this JSON object will be parsed as a product inside of the CreateNewProduct. So because we use the same property names for our keys inside of the JSON object, we can use this as a product object inside of the REST API. So let's send this one. And back we get this. So we get a new product that has ID number 1 because we set the database to auto increment IDs. So we supply it some data and it gets us back some new data. And that's wonderful, right? So if we go to get and we just write this, this is our get all products method that we're gonna try to query now. We'll get back an array containing this one product, right? So why do we do that? Well, created one product and we're getting all, and there is only one inside of there. So let's try and make a new product. New product number 2. And it has price 20. Post this. Get products, and of course when we make a get request, we don't really use this for anything. There still is a body inside of a get request, but it's by convention always ignored. So the get method we have here doesn't use anything. And now we get our 2 products back. And this is all right. The problem with this controller right now is that the controller essentially always just has one thing it will do, no matter what the client supplies of data. So let's say that the client supplies some data that we don't want to allow, or maybe there are some keys inside of our entities that are ignored. Then we can start to get some problems. So what we want to do now is we want to make some validation to make sure that the data that we are supplied by the clients live up to our expectations. So we're going to use something called Fluent Validation for this. To install Fluent Validation, just pick whatever project you want to do the validation in. Typically, you would have other projects for a solution like this, so you might have a project called service or something. We don't have that right now, we just keep it very simple, but we're just going to search for Fluent Validator. And I think if you just write Fluent, it'll come up like this. There's also something called Fluent Assertion Sensor and a bunch of other stuff. There's a lot of things named almost the same. Just install Fluent Validation. I use version 11.2.1 and I just install it into the API project. And we can just confirm that we have an installation by going to packages, and we should be able to see Fluent Validation just in a moment. Yeah, here it is. It can take a little while to install some of these packages, so you might have to wait just a little bit. If we minimize this one and just make a new class, and we can call that class ProductValidator.cs. And the product validator has to implement an interface, and this interface comes from the Fluent API library, and it's called Abstract Validator, and it has diamond brackets that we're gonna put our entity inside. So of course, if you can't put your entity inside of it, it's because it needs the reference. So make sure that you have the entity project inside of your dependencies. We have it right here. And then you're going to use the using keyword. So we're using entities, and then we can access product. So what we're going to do here is we're going to make a constructor. We've been making a whole lot of constructors, right? We're going to make one more, and product validator. And then we make empty parentheses. I think it says I have a typo here. I probably wants to do a validator, and let's just change the name real quick. Product validator, like this, and even the file out here also changes as well, and there's no complaints anymore. And then let's make some rules. So let's make a rule for our products. So we have this funny arrow syntax here, and we say that the price, for example, should be greater than 0, because of course if we have a negative price to a product, there's probably something wrong. So by now we're just chaining together some functions that are built into this Fluent Validation framework. You can make your own custom validators with Fluent Validation, but for now we're just going to use some of the built-in stuff. Let's make another one that says rule form, and we're going to make arrow syntax again, and let's just say that the name here should be not empty. So what does not empty even mean? Well, not empty means that it's not allowed for something to be null, or a string of length 0 or white space, or anything that would be to a human conceived as empty. So that's great. We don't have to write a whole lot of conditionals like not null, not space, and whatnot. So this Fluent Validation can simplify our rules for our products a lot. So what we would do now is we need to actually use this validator class we have. So the product validator, it says here, it's never used. And that's absolutely true. We just have a class, but the class is not in use. So what we can do is we can go to the controller, and then we go to the post function where the client sends some data to us. And what we're going to do now is we're going to make an instance. So we can make an instance many different places. Let's make an instance variable here, a private product validator, and we're going to call it product validator. And just going to say product validator equals new product validator. And now let's validate this product thing that a client wants to post. So before we send it to the database, before we do anything with it, we want to use the rules we just defined. So what we're going to do is we're going to say validation. So we can make an implicitly typed variable here. We call it validation equals validator dot validate. Yeah, there's a whole lot of words repeating here, and then we put the product in here, and I'm just gonna explain to you what this even means. So this local variable we have here is supposed to figure out, is this product valid? And how do we figure out if it's valid? Well, the product validator here is an instance of the class we just created in here, right? And now it's not gray anymore, which means that it's in usage. So we can go back here and we can just write dot is valid, like this. So this is a Boolean. So we can say if validation. So essentially in here we just say if true or if false, because this is a Boolean. So if true, we return this, else, and we don't even have to write else. We can really just write return, because there already is a return statement in here. So we can simplify the code by not writing an else statement, and then we write return, and then we have to make what's called a bad request response. So we're going to tell the client that because the validation failed, there is something wrong with their response. But before we get so far, we need to change the return type of the function here. So right now we return a product, but we actually want to either return the product, or we want to return a bad request response. So what I can do is I can write ActionResult. And what I have to do here is I have to let the client know that this is all right. So I can make an OK function, and then I just put this into the OK function. So I say, this is a status code 200. Technically, we would use a 201 in real life, but right now we just make something simple. So as long as it starts with 200, it means it's successful. So this is all right for now. And if else, we're gonna return bad request. And inside of the parentheses here, we're gonna write the message. And luckily, the message is very easy for us to get because we're using Fluent Validation. So we can just write validation.toString. And this validation will create a message. You can create your own custom messages if you want. But by default, there already exists a message like this price should be greater than 0. Name should not be empty, and so on. So let's test this. We go back into a terminal. We made some changes, so now we're gonna rerun the program. And now it's gonna build again. We go into our post requests here, and let's modify this body now. So now the client sends some data where the name is empty and the price is negative. And as soon as we have the program running here, let's get a sip of coffee. Delicious. We're ready now, and I'll click send. And we get this false here. Of course, if we want to get something that's a little more descriptive, let's go back into the controller here. We wouldn't return the boolean straight away, so we can just delete this is valid and then put is valid here. Now we rerun the program. And now we're ready, and we click send. So not only will we get a message back here, we of course don't write anything to the database. So now we get a 400 status code back. It says bad request, and we know by now that our API restricts some data using the validation. So now I just minimized JetBrains Writer because we're not going to look at the IDE for a moment. We're just going to look at Postman, because what we're going to talk about now is API testing with Postman. So now we have some data coming out of the API. We write requests and we get some data back, right? But how do we know that the API is always responding the way that we want it to? So conveniently, Postman has built in something called tests. Inside this test tab, we write JavaScript code for tests. So an example of a test could be using one of these snippets out here. So we have a bunch of stuff. A lot of this up here is about environment variables. We don't want to do that. We want to use status code, for example. So what we want to make sure is that when we call this address with a GET request, that we get status code 200 back. And let's send this now. And we get a 200 back. And the tests can be found inside of here, test results. So it'll say status code is 200, and it means it was a successful read. And that's what we would expect, because right now it's running, right? But where this starts to shine is when you make post requests that have a lot of data inside of the requests. So let's try and just save this one. We can put it inside of this collection, and we just press save here. So we have this little request up here that we can always go back to later. And then we make a new request here, and we're just gonna start off by making HTTPS localhost port 5001 / product, and then we pick post here. And now we do the thing that we do. Pick a JSON, and now we're gonna give it some data. So first off, we're gonna try and see if we can make a post request return a 404. So let's have a name that is empty. No, that's not allowed. And let's try and have a we don't care about IDs, right? We care about price. So have a price that is valid after all. And we write send. So of course we get this name must be empty back. And now we define a test, so we can actually use the code snippet that we used before and just modify it, because we know that this is supposed to be a 400. And we can write when name is empty, get return a 400 bad request, right? And now we have a test, and the test adheres to the request here, and it adheres to the body. So when we send this, we can go back into the test, and we see that there's a test that passes, because of course we expect it to fail, and it fails. And we would also go and save this one now. And we just press save, and now we will say post here. We can give this one a new name. So let's rename, and let's say failing post due to empty name. And let's make one that is a successful post now. HTTPS localhost port 5001 product, and we do what we always do: go to body, go to raw, go to JSON, and now we put in name, cool new product, price 420, and we write a test for this one. So right now we can just keep using this one because we're just looking at the status codes, right? And we expect to get a 200 back. So we have a successful response, and it is successful because right now we're not getting a rejection because there actually is a name right. So let's also save this one. And we can just name it successful post product. And inside of this collection, we have a bunch of requests now. And let's say we just want to send them all. So what we can do is we can write run collection. And then we can write a new collection, and we will get this test runner, and we'll see that our tests pass. So now it's making a request, and then another request, and a third request. So once you start getting a lot of endpoints, start making tests for all your HTTP requests inside of Postman. And then once you start adding some new features, before you commit the changes you have to your code, and before you start making any deployments of your code, go into Postman and just run through all of the endpoints like this. So maybe make like 3-4 different tests for every single endpoint, and just figure out, are all these endpoints still working? This way, we still test the entirety of the application. The thing is, we don't necessarily figure out exactly what is wrong when some test fails, but we do know that there is a failing test, and we can use this information to then go and search what is wrong, because then a unit test can pinpoint what is wrong. But this is not a unit test, this is an API test, and this is to figure out, do our general features inside of our application work from the API side of things?